Awesome. And, okay. Give me a second. Page 93. You know, sometimes the digital version differs a little bit from the print version. So I'm going to pick one and read it and make sure that that's what you want to see. So like this one's probably pretty straightforward. It's number 5 on page 93. It says the consumer price index, which measures the cost of a typical package of consumer goods, was 201.6 in year 2006. Let's write that down. So just scroll down a little bit. So this is page 93, number 5. It says the consumer price index, which that doesn't really matter to the problem, most likely. Typical packaged consumer goods, 201.6 in year 2006. And probably this is an input value for our function. This will be an output value for our function, but I'm putting this arrow in this direction for now anyway, because it's the order I'm reading it in. And then 224.9 in year 2011. And right now I've got my phone playing. I'm going to mute that because it's hard to talk while I can hear myself. It says let x correspond to 2006. Okay, so we're going to say x equals 6 corresponds to 2006. Therefore, this will be x equals 11 will correspond to 2011. Estimate the CPI in 2008. That's going to be an interpolation. It's data between, or not data, but a value between our data points. And then also 2015, that will be extrapolation, a value outside the data point. So I need a line for this. Basically, this, let me full screen this. This guy here, this set of values, this gives me the 0.6 comma 201.6, and then this one here gives me the 0.11 comma 224.9. You know, if we're thinking in terms of a linear function. So the slope of that linear function is going to be the difference of the y coordinates divided by the difference of the x coordinates. I should point out that I'm using Google Hangouts to broadcast this, but I don't think you can speak to respond, but you can definitely type in the chat if you want to ask something or just respond to the same email. And I'll try to pay attention. It's on another screen, but I'll try to pay attention to that as well. So it doesn't matter which one I call the second one, but I'll say that this one is the second point, just so I know what to put in that first position for both of these. So I'll have 224.9 minus 201.6 over 11. That's a wonky 11. 11 minus 6. So that's going to be, what is that, 23.3? I'm going to have to reach for a calculator at some point. Over 5, that's going to be a 4.66. No calculator yet. And then I'm going to use, there's more than one way to do this. You can use the slope-intercept form for a line or the point slope-intercept. And I'm going to use that one because I know it. It's easier, I think. If you do know that one, this is the one that you should use. So y equals m times x minus x1 plus y1. Okay. And yeah, I'm just going to plug in. I called this the second point right here. So I guess this guy over here is the first point, just by default. So x1 and y1 are 6 and 201.6 respectively. So this equals 4.66 times x minus 6 plus 201.6. Now there is, this equation as it is now will be functional. It'll work because we're asked for in the question, what about 2008 and 2015? All So that would be x equals 8 and x equals 15. So I don't have to distribute this 4.66 across x and then combine like terms. I don't need to do that, although I can. I think just in the interest of speed, we won't do that. So if x equals 8, then y equals 4.66 times 8 minus 6 plus 201.6. Okay, so that's going to be 4.66 times 2 plus 201.6. Rewrite that a little bit neater. Sometimes this is going to look a little off because a couple months ago I bent somehow the tip of the stylus. It's replaceable, but you know, haven't gotten around to it, so sometimes my writing will be a little weird. Anyway, so that's going to be 9.32 plus 201.6. And then when we add that up, we get 210.92. So unless I've made an error somewhere, which, you know, of course is possible, then this should be the interpolated CPI for 2008. And then if we want 2015, we'll use x equals 15. So y equals 4.66 times 15 minus 6 plus 201.6, and that's going to be 4.66 times 9 plus 201.6. Starting to. Okay, we'll try to continue without a calculator. So it's going to be a 4941. And you know, if you're watching and you want to check with the calculator, just let me know if I've made a mistake. There's about a 12 to 15 second delay, I think. Plus 201.6. So this is going to equal, what is that, 243.54? And that should be the CPI for 2015. And all of these pretty much go the same way. You just have to identify, shuffle some paper right here. You just have to identify, okay, what information might be given. I'm told that these are linear models or linear problems, so I don't have to, you know, decide, oh, is this linear? I know that. So feel free to type a question, or if that was totally clear, you can put totally clear in an email or a comment. The live chat's probably, I'm looking right at it, that might be easiest for me anyway. We can certainly do more of those. We can certainly yeah, any one of them after that. Of course, there's a delay, so I should probably take that into account. And while we're at it, little boxes around our answers. Okay, well, that's enough for the delay. For the delay to catch up. I would thank you directly for asking the question, but I don't necessarily know if you want your name on the internet, so I'll just say thanks for suggesting the question. There's only one person here, so it's you. I'm talking to you that asked it, and no one else. Tell you what, there's a lot of problems on this page. I'll just pick another one. Let's see. Okay. Yeah, the residuals. I don't want to stress doing residuals by hand that much because generally you just have Excel do it for you to do linear regression. The purpose of having you do the residual problem, handwritten, was just that you understand what it means. What does the calculation represent? Because you can just read a description, and then you have Excel do it. You go, oh, r squared is 0.72. Okay, what does that mean? Whereas if you've done it by hand, it's I think much clearer to you what goes into it because you did it yourself. So I don't want to do those. That would just take up time. Let's look for one a little bit later in this section. How about this one says, this is number 19 on page 94. Here's a table with a bunch of numbers. Now, are we looking for, it's least squares, yeah. I can change this setting so that I'm showing my whole screen and show how to do that on Excel, but I don't know if that's something that you want to see. While you're ruminating on that, nope, you're gone. Okay, so I'll wait and see if anyone else shows up. I might cut this short if no one else takes part soon. What I am going to do, let's see. Light works. Yeah. Okay. Oh, yeah. Sorry, I tabbed away. Yeah, I can do another one. I missed your message there. Yeah, let's just do another that's the same. Let's do number 10. It's a little bit different. It says a ski resort requires large amounts of water in order to make snow. Yeah, that seems reasonable. Sure. Snowmass Ski Area in Colorado plans to pump at least 1,120 gallons of water per minute for at least 12 hours a day from Snowmass Creek. Between mid-October and late December, environmentalists are concerned about the effects on the ecosystem. Find the minimum amount of water pumped in 30 days. Hint, why be the total number of gallons pumped X days after pumping begins? Okay. So this one, maybe I was just thrown off by the wording. One thing I want to point out is that you're given different units of time, gallons per minute, hours per day. Sometimes those values don't matter. That you just treat this number is correlated with that number. This is an X value, that's a Y value. You don't worry about units at all. This one is we're asked about find the minimum amount of water, right? And we're pumping 1,112 gallons per minute for at least 12 hours per day. So 1,120 gallons per minute for least 12 hours per day. And then the question is, find the minimum amount of water pumped in 30 days. So then the hint says that X is the number of days. So basically, we have to turn this into an amount of gallons per day in order to get started, and then that times X is just the amount. There's no y-intercept for this, because if you pump water for no days, right? If X is 0, because X is going to be number of days, right? If you pump water for no days, well, if you pump water for 0 days or no days, that's no water. So you're, something like this one. We didn't work this out, but if you have equals mx plus b, the y-intercept, well, that's the outcome of putting in 0 of whatever x is, right? So for this one, that would be 0. Hopefully that's clear by now. I've rambled a bit. So there's a couple things to consider. When you are dealing with units, you want to treat them like fractions. They behave very much the same way, which is why I'm writing them like fractions, because that's how they behave when you use them in algebra and arithmetic. So I'm first going to convert, it doesn't matter which one, but I'll convert this one into gallons per hour rather than per minute. So I have 11, there's 2 ways to do this. There's a method that is common in chemistry and physics. I'll not do that. I'll just make it maybe a little bit more straightforward. So I want to turn this into gallons per hour. So I need to convert minutes into hours. So I need to say, well, there's 60 minutes. In fact, let's do it this way. There's times 60 minutes per hour, right? 60 minutes per hour. Or if you want 60 minutes in 1 hour. Notice that what I'm doing here is this whole thing equals 1. 60 minutes divided by 1 hour. Well, the top and bottom are equal, right? Because 60 minutes is 1 hour. So that's just 1. So when I multiply by 60 minutes per hour, I'm multiplying by 1, meaning I'm not changing anything really. I'm changing the way it's written, but not the actual quantity. And basically, let me change colors here. Just real quick. These minutes cancel. Is that the one I wanted? Yeah. These minutes cancel just like fractions would. Just like if you have 2/3 times 3/5, right? And these 3's can go away. Same thing. The minutes go away. Sorry about that artifacting on the screen there, which happened 12 seconds ago. Sorry. So I'm going to get gallons per hour this way. So I just need to do 1120 times 60. So that's going to be 67.2. Is that right? 67,200 gallons per hour. Right. Now, that means that y, the number of gallons, equals 6720x. Because if I take gallons and multiply by hours, keep in mind, let's do it this way. This guy is a different color. Yeah, orange is good enough, I guess. This guy is gallons. The 67.2 is gallons per hour. Oh, I've forgotten something. Yeah, we could do something from 15 through 18, sure. I've made a mistake. We're not quite done. I need gallons per day, not per hour. So I need to backtrack. That's okay, though. That's fine. So I'm just not done here. I need to do more. Okay, so I need to multiply by, well, now I need to turn hours into days. So 24 hours per day. That, the hours will cancel. And that way I will get gallons per day. So I'm going to break out the calculator at this point because these numbers are getting big enough that, yeah. So 1,612,800. This is gallons per day, which is a lot, obviously. And at this point, since I know I just need to multiply the two, I really don't need to use an equation like this anymore. So I know I'm just going to multiply this with 30. But I want to highlight the idea anyway. So that number there is not gallons per hour. This is gallons per day times, well, X is in days, right? That's what we had from before. X is the number of days. So this is days, and I said earlier, it's work like fractions do. The days cancel, so everything matches up. The right-hand side here actually is in gallons. It's gallons per day times days. So there we go. So the question asks, where is it? Find the minimum amount of water pumped in 30 days. Well, that just means X equals 30. So Y equals 1,612,800. No, yeah, 800. There we go. Times 30. So this is a big number, obviously. 48,384,000. 48,384,000. 1,384,000. And generally, you're not going to have to worry about units on, the online tests, or when we get to the midterm, it's multiple choice, so you don't have to worry about that. But this, of course, is in gallons. That should be the right answer. So 15 through 18. Yeah, okay, so here's what I'll do. Because that mainly is done through Excel. I'll have to fiddle with my setup here, but hopefully nothing goes wrong. So, come on, you can do it. So, I'm going to share my whole screen, and of course that happens. So let's quickly get that out of there. There you go, yeah. So now I'll pull up Excel. And I'll do let's do 17. So it says the accompanying table shows the revenue in billions of dollars from newspaper publishers. I wonder why Census Bureau knows that, but okay. And there's a little table of some numbers. So I'm going to type in, I'm not going to use 2000. Yeah, part A says find a linear model for the data with X equals 6 corresponding to the year 2006. So I'm going to go ahead and type in 6, 7, 8, 9, 10 for the dates. I'm using a tiny keyboard with no number pad on it, so this will be a little dicey. Hopefully there's not too many errors. 48.9, 8.9, 47.6, 43.9, 36.4, and 34.7. So I'm going to highlight all that. I'm going to go to Insert, and then in the Charts area, I don't remember what version of Excel this is. I think it's the newer one. So yours might be different, and maybe you're using numbers if you're on an Apple product. So I'm going to select the scatter plot with no dots at all. And then I'm going to go and probably start by making this chart bigger. There's more than one way to do this. Like I think if you select that blue dot, no, it doesn't show up there. The way I typically do this is I right-click on a blue dot and go to Add Trend Line. I'll make sure the options are set to linear, and then I will display the equation on chart. And what we'll do is display R value, so I can see how accurate that is. So it looks like y equals, that's really tiny. I probably can. Uh-huh. Can. But will it want to? It doesn't want to. Okay. I'm not going to fool with it. So y equals negative 3.96x plus 73.98. You know what? Maybe I can. Well. Yeah, it just does not want to do it. Okay. See if I can paste that over here. So this is number 17. It's 94. Okay, yeah, that's technically there. That counts. So y equals negative 3.96x plus 73.98. Right, and then we're gonna look for a. Oh, well, there we go. There's the formula in my teacher's edition. You know, I really could have just cheated and pretended to done this because I have the answers right here. Anyway, assuming the trend continues, estimate the revenue in 2016. So that would be x equals 16. So that will mean that y equals negative 3.96 times 16. Here's an interesting question. In the model, oh, the y-intercept that you're getting is incorrect. Yeah, I'm not sure I've ever used an Inspire CX. That there might be a setting or something. I don't know. I would recommend for those problems, you know, on the midterm, you know, that's on campus, I'm not going to have you do a linear regression on a calculator, just because a lot of people have used Excel to do it, you know, for the challenge, and then you can't use Excel during a test. So I'm not going to put that on the midterm. So don't worry about that, about knowing how to do it with your calculator specifically. You just need to know how to do it on Excel, basically, or a calculator, either one, because at some point you might need to do this for a later course, but I'm not going to have you do this on the in-class test. So don't worry too much about that. Let me pull up. Did you submit the challenge even though you didn't finish it? I don't remember if you emailed me about that. I'm going to take a quick look. Give me a second. And this was 2.5. No, that'd be 1.5. Yeah. Well, I'm not sure what to tell you about that now. You know, it's a bit late. Really, it would have been better if you had. Well, anyway, that's not something I should discuss on this live stream that others will see later. So maybe we can discuss that another time. But yeah, if the calculator you're using has extra settings that might disrupt what you get, that's a possibility. The don't know. I'm not sure what was causing your issue, so I can't say what did that exactly, unless it was just a problem. Okay, well, I can look at what you have, when I go to. So you emailed it to me, right? Yeah. Well, yeah. I mean, I'll look at it, and we'll see. We'll see how that works out. I haven't started grading those yet. I'm going to do that probably tomorrow. So tomorrow evening, I might be done with grading those. So where were we? So plus 73.98. So I was going to say about this problem is, before you get an answer, it might be interesting to think about why is there a negative number here? So this represents the revenue of newspaper publishers. So it's not surprising that it's negative. With your calculator, I don't know, because I don't have one in front of me. On Excel, you do it just the way I showed you. You were able to see the Excel version, right? Did I do it too quickly and you weren't able to follow it? I've done it a bunch of times, so maybe I just ran through it too quick. Let me see if I can pull up the email you sent me. Okay, there it is. Let's have a look. Okay, yeah, I'm looking at the screenshot from the calculator. Yeah, I don't have in front of me what the correct numbers are for the challenge itself. I have them just not right in front of me. But yeah, the B value does look a little off. And I can certainly look at whether the table you sent doesn't include column A. So I can't tell if there might have been an error in column A, maybe. And then column B, I can tell those are the values, and I recognize those numbers. I've typed them a bunch of times. Okay, well, it is one assignment. It was worth a lot of points, but it's only one assignment out of one module, so yeah, I'm not prepared right now to tell you what I think the grade will be, but I can see that you were using a calculator. You looked at what it was giving you. I'm not sure what you mean by right on target, but yeah, this can be replayed. I'm probably going to make it unlisted and then take the video, cut out the parts where nothing was happening, and put the clips back up as here's us working a problem, and here's us working another problem. That way people don't have to scroll through or scrub through 20 minutes of me waiting for nothing, right? And then this conversation is not going to be interesting to anyone else. So I'll probably cut the video into pieces. Anyway, I'm going to go ahead and finish this value here. Negative 3.96 times 16 plus 73.98. And I get 10.62. So that would be the revenue in billions for newspaper publishers in 2016, which makes sense. Newspapers are being replaced with other media, and just people don't only buy newspapers. I can't remember the last time I bought a newspaper. Vaguely, I can remember, when I was a kid, I could go buy a newspaper for $0.25 or something. Other than that, I don't remember buying one in recent memory at all. Just because, you know, got the internet in my pocket. Why would I buy a newspaper? Okay, yeah. All right. Well, it's just about 2 o'clock. Thanks for showing up and asking questions. Hopefully, the next one, I haven't decided when it will be. I think the idea I had is that, you know, if the module is 6 days long, then the fourth day is, you know, more than halfway through that time. People have had a chance to go through the module, looking at the material, the videos, trying the practice problems. And at that point would have questions like, how do I do this? How do I do this? And then so the fourth day, maybe the third day is better, but I was thinking the fourth day would be a good place to do it. And then the next day, you know, the exam is available. And then the next day things are due. So the fourth day seemed like a good time to be open for questions. I think what I might rather do next time is just say, okay, email me your questions, and when I have enough questions to fill an hour of time, then I'll do a live stream, and it'll still be visible, you know, available. That way, I can just work the 5, 10 problems, whatever it is, in an hour. And if anyone who's able to watch can ask questions if they want. Yeah, rather than having, I'm gonna do a live stream and maybe have nothing to talk about, would it be better to do it the other way? Have another join. Yeah, I'm not. You mean besides having a graphing calculator, or that there should be? It would be good if there was some other way, because your A value, or I'm sorry, M value, I'm guessing was correct, or you felt like, oh, this makes sense. I'm not sure how you decided that the B value was incorrect, aside from thinking, oh, this seems wrong. So do you mean having something totally different? You didn't realize you could use a totally different tool, or I'm guessing that's what you meant. Maybe you were thinking that you had to use a graphing calculator. The B equating to the, if specific to any of the exercise examples answers, and you right on target is explaining another technique for linear model least regression. Okay, yeah, just use Excel basically. Okay, and also I don't know if the chat will show up later. I think it will not, but I'm not certain. So I don't know. I think it's just about 2 o'clock, so I think we can just end it there. Did I answer both questions? I did. I think we can just end it there, and then I'll figure out. Maybe you have a suggestion, since you were on the other end of this. You know, what would be a good way to receive the live stream, or any suggestions you may have would be welcome. But I'll figure out how I want to format the next one, just so it's a little more efficient. It was sort of thrown together, I guess, but this is the first time I've done this. Okay, well, I guess that's it then. So thanks for watching, and I will talk to you later. How do I do that? How do I turn this thing off?